In our previous classes, we have read that a chemical change is a permanent change. It cannot be reversed. For example, curdling of milk and rusting of iron. Whenever chemical change occurs, the nature and identity of the initial substance or substances changes and a new substance or substances is formed. We can say that a chemical reaction has taken place. Now the question is how to know that a chemical reaction has taken place. The answer is at least one of these four will occur. Change in state, change in color, evolution of gas, or change in temperature. Let us see some examples. Lead nitrate is a colorless crystal or white powder. Its aqueous solution is clear and colorless. Potassium iodide is a white powder. Its aqueous solution is clear and colorless. Lead nitrate and potassium iodide react to form lead iodide, which is a yellow precipitate. In this chemical reaction, you see change in state as well as change in color. Zinc granules are silver gray in color. When they react with dilute hydrochloric acid, colorless zinc chloride is formed. In this chemical reaction, you see change in state, change in color, and evolution of a gas. If you touch the conical flask or test tube in which reaction is taking place, it will be warm. Magnesium ribbon, which is silver gray in color, burns with a dazzling white flame and changes into a white powder. This powder is called magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. In this chemical reaction, you see the change in color. Any chemical reaction can be written in three forms. First, in a sentence. Second, in a word equation, and third, in a chemical equation. Let us understand this with an example. When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This is representation of a chemical reaction in a sentence. The word equation for the above reaction would be this one. Chemical equations can be made more concise and useful if we use chemical formula instead of words. For example, magnesium is represented by Mg, oxygen by O2, and magnesium oxide by MgO. Now let us talk about the structure of a chemical equation. These are called substances. Substances are elements or compounds that participate in a chemical reaction. The substances that undergo chemical change in the reaction are the reactants. The new substances formed during the reaction are called products. The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. If the number of atoms on the left hand side and right hand side of the arrow are same, equation is balanced. If not, then equation is unbalanced. An unbalanced chemical equation is also called a skeletal chemical equation for a reaction. Now let us talk about how to balance a chemical equation. As per the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Let us see if this chemical equation is balanced or not. There is one iron atom on the left hand side and 3 iron atoms on the right hand side. So iron atoms are not balanced. There are 2 hydrogen atoms on the left hand side and 2 hydrogen atoms on the right hand side. So hydrogen atoms are balanced. There is one oxygen atom on the left hand side and 4 oxygen atoms on the right hand side. So oxygen atoms are also not balanced. Overall, the chemical equation is not balanced. First important point to remember is we cannot alter the formula of the elements or compounds in the reactions. For example, Fe cannot be written as Fe2 or Fe3. H2O cannot be changed to HO2 or H2O2. Fe3O4 cannot be changed to Fe3O5, Fe2O3, etc. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. This unbalanced chemical equation has 4 substances. Out of these 4 substances, Fe3O4 has got maximum number of atoms. They are 7, 3 iron atoms and 4 oxygen atoms. Oxygen atoms are more than iron atoms, so we will start balancing oxygen atoms first. There is one oxygen atom on the left hand side and 4 oxygen atoms on the right hand side. So we will write 4H2O on the left hand side. So there will be 4 oxygen atoms on the left hand side and 4 on the right hand side. Now there are 8 hydrogen atoms on the left hand side, 4 into 2, and only 2 hydrogen atoms on the right hand side. So we will write 4H2 on the right hand side. So the hydrogen atoms on the right hand side will become 4 into 2 means 8 hydrogen atoms. So hydrogen atoms will be balanced. Next we will see iron atoms. There is only one iron atom on the left hand side and 3 iron atoms on the right hand side. So we will write as 3Fe on the left hand side to balance the iron atoms. Now every element, iron, hydrogen and oxygen, have same number of atoms on the left hand side as well as right hand side. So this is a balanced chemical equation. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient, as we have just seen. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous state is represented by small g, liquid by small l, aqueous by AQ, and solid states by small s. The word aqueous AQ is written if the reactant or product is present as a solution in water. Let us see this example. Lead nitrate and potassium iodide react to form lead iodide, which is a yellow precipitate. Lead nitrate, potassium iodide and potassium nitrate, they are aqueous solutions. So we write AQ next to them. Lead iodide is solid, so we write S next to it. Down arrow is precipitate symbol. Let us see example 2. Zinc granules are silver grey in color. When they react with dilute hydrochloric acid, colorless zinc chloride is formed. So zinc is solid, so we write S next to it. Hydrochloric acid is aqueous, so we write AQ. Zinc chloride is aqueous, so we write AQ next to it. And hydrogen is gas, so we write G next to it. Upward arrow is the symbol of gas. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. Let us see these two examples. Carbon monoxide gas reacts with hydrogen gas at 340 atmospheric pressure to form methanol or methyl alcohol. 340 atm is written above the arrow. In the second example, aqueous carbon dioxide reacts with water in the presence of sunlight and chlorophyll to form glucose, aqueous oxygen and water. In chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. Let us understand what does this mean. In this chemical reaction, there are 4 substances, 2 reactants and 2 products. There are 3 elements, iron, hydrogen and oxygen, participating in this reaction. Now point number 1, atoms of iron will not change into atoms of hydrogen or oxygen. Similarly, atoms of hydrogen will not change into atoms of iron or oxygen, and atoms of oxygen will not change into atoms of iron or hydrogen. Point number 2, number of atoms of iron, hydrogen and oxygen will neither reduce nor increase. They will remain the same before and after the reaction. Only difference will be bond between hydrogen and oxygen atoms will break. Oxygen atoms will form bonds with iron atoms and Fe3O4 will be formed, while hydrogen atoms will form hydrogen molecules. There are 5 types of chemical reactions. These are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, and redox reactions. We will see them one by one. First one is combination reactions. When two or more substances combine to form a single product, the reactions are called combination reactions. Let us see some examples of it. First one is calcium oxide, which is quicklime, reacts vigorously with water to produce slaked lime, which is calcium hydroxide, and a large amount of heat is liberated. Here two substances are combining to form a single product. That is why it is a combination reaction. Second example, coal burns in air to form carbon dioxide gas. Here two substances are combining to form a single product, so it's a combination reaction. Third example, hydrogen and oxygen gases combine to form water. Here again, two substances are combining to form a single product. That's why a combination reaction. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Here in example 1, two substances are combining to form a single product and a large amount of heat is getting released. That's why it is an example of exothermic chemical reaction. Few other examples are natural gas methane burns in air to form carbon dioxide, water, and heat is released. That's why it is an example of exothermic chemical reaction. Another example is respiration. We need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. Example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration. So respiration is an example of exothermic process. The decomposition of vegetable matter into compost is also an example of an exothermic reaction. Now let us talk about decomposition reactions. In a decomposition reaction, a single reactant absorbs heat or light or electricity and breaks down to give simpler products. Let us see few examples of it. First example, ferrous sulfate crystals, which are green in color, lose water when heated and the color of the crystals changes. It then decomposes to ferric oxide, Fe2O3, which is reddish brown to black in color, sulfur dioxide gas, and sulfur trioxide gas. When a decomposition reaction is carried out by heating, it is called thermal decomposition. On heating, lead nitrate, which is colorless crystal of white powder, decomposes to nitrogen dioxide gas, which is brown in color. Another example is white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Another example is on electrolysis, water decomposes to hydrogen and oxygen gases. Reactions in which energy is absorbed are known as endothermic reactions. Words like heat, sunlight, or electrolysis are written over the arrow to indicate endothermic reactions. These three reactions are endothermic reactions. Now we will talk about displacement reactions. A chemical reaction in which a highly reactive element displaces a less reactive element from its solution is known as displacement reaction. For example, iron, which is more reactive than copper, displaces copper from copper sulfate solution. Similarly, zinc, which is more reactive than copper, displaces copper from copper sulfate solution. In the same way, lead, that is more reactive than copper, displaces copper from copper chloride solution. Next is double displacement reactions. A chemical reaction in which part of one reactant is replaced by part of another reactant is known as double displacement reaction. There is an exchange of ions between the reactants. Let us understand this with the help of these examples. Barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. Barium chloride is made of Ba++ and Cl- ions. Similarly, sodium sulfate is made of Na plus and SO4 ions. Ba++ combines with SO4 to make BaSO4. Similarly, Na plus combines with Cl- to make NaCl. This way, exchange of ions takes place. Lead nitrate reacts with potassium iodide to form lead iodide and potassium nitrate. Lead nitrate is made of Pb++ and NO3- ions. Ki is made of K+ and I- ions. Pb++ combines with I- to make PbI2. Similarly, K+ combines with NO3- to make KNO3. Next one is redox reactions or oxidation and reduction reactions. A chemical reaction in which one reactant gets oxidized while the other gets reduced. Such reactions are called oxidation-reduction reactions or redox reactions. If a substance gains oxygen or loses hydrogen during a reaction, it is said to be oxidized. Whereas if a substance loses oxygen or gains hydrogen, it is said to be reduced. Let us understand this with the help of these examples. In first reaction, a mixture of copper oxide and hydrogen is heated to make copper and water. Here H2 is gaining oxygen to make H2O, so it is oxidized. CuO is losing oxygen to make Cu, so it is reduced. In second example, zinc oxide reacts with carbon to make zinc and carbon monoxide. Here carbon is gaining oxygen, so it is oxidized. ZnO is losing oxygen to make Zn, so it is reduced. In third example, manganese oxide reacts with hydrochloric acid to make manganese chloride, water and chlorine gas. Here HCl is losing hydrogen to make Cl2, so it is said to be oxidized. Remember in definition, a substance which either gains oxygen or loses hydrogen is said to be oxidized. MnO2 loses oxygen to make MnCl2, so it is reduced. Now let us see a couple of disadvantages of oxidation. First one is corrosion and second one is rancidity. We will see corrosion first. When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. For example, rusting of iron, black coating on silver, and green coating on copper. Iron reacts with oxygen in the air to form ferric oxide Fe2O3. Fe2O3 then captures moisture in the air and gets converted to Fe2O3.xH2O, which is brown color substance known as rust. Silver reacts with hydrogen sulfide in the air to form silver sulfide, which appears as black coating on silver. Copper oxide reacts with moisture in the air and carbon dioxide gas to form copper carbonate, which appears as green coating on copper. To prevent corrosion, there are a couple of well-known methods. First one is galvanization. Galvanization is the process of applying a protective layer of zinc on a metal. It is a very common method of preventing the rusting of iron. Second one, many types of coatings such as paints or varnish can be applied to the surface of the exposed metal. Second disadvantage of oxidation is rancidity. When fats and oils are oxidized, they become rancid and their smell and taste changes. They emanate foul smell and taste bad. To understand it more clearly, leave the oily food exposed to air for few days. After few days, their freshness will go away. They will smell and taste bad. There are few methods to prevent rancidity. First one, antioxidants are added to foods containing fats and oils. Second one, keeping food in airtight containers helps to slow down oxidation. Third one, chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized. Now let us see some practical use of chemical reactions. First one is, a solution of slaked lime is used for whitewashing walls. Calcium hydroxide reacts slowly with carbon dioxide in the air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. Second one is decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. Third one, these reactions are used in black and white photography. First one is white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Second one, yellow silver bromide turns grey in sunlight. This is due to decomposition of silver bromide into silver and bromine by light. Let us see questions and answers. First question, why should a magnesium ribbon be cleaned before burning in air? Answer is, magnesium reacts with oxygen in the air to form magnesium oxide layer which prevents burning of ribbon. This layer needs to be cleaned before burning the ribbon. Second question, write the balanced equation for the following chemical reactions. First part, hydrogen plus chlorine react and make hydrogen chloride. First, we will replace substances by their chemical symbols. Hydrogen by H2, chlorine by Cl2 and hydrogen chloride by HCl. Now we will balance. All the three substances have two atoms. H2 has two atoms of hydrogen, Cl2 has two atoms of chlorine and HCl has one atom of hydrogen and one atom of chlorine. So we can start from either hydrogen or chlorine. On left hand side there are two hydrogen atoms and on the right hand side there is only one hydrogen atom. So we write 2 before HCl. Now there are two hydrogen and two chlorine atoms on right hand side as well as on left hand side. So the equation is balanced. Second part, barium chloride and aluminium sulfate react to form barium sulfate and aluminium chloride. We will write BaCl2 in place of barium chloride, Al2SO4 thrice in place of aluminium sulfate, BaSO4 in place of barium sulfate and AlCl3 in place of aluminium chloride. This is a skeletal chemical equation which we have to balance. First step is to find out the substance which has got maximum number of atoms. Aluminium sulfate has got 2 aluminium atoms, sulfur atoms 1 into 3 means 3 atoms, oxygen atoms 4 into 3 means 12 atoms. Since oxygen atoms are maximum in number, so we will balance oxygen atoms first. On the left hand side there are 12 oxygen atoms, on the right hand side there are 4 oxygen atoms. So we will write 3 before BaSO4 to make the oxygen atoms on the right hand side 3 into 4 means 12. Now the oxygen atoms are balanced. Next we will see sulfur atoms. On the left hand side there are 3 sulfur atoms, on the right hand side there are 3 into 1 means 3 sulfur atoms. So sulfur atoms are also balanced. Next we will see aluminium atoms. Aluminium atoms are 2 in number on left hand side and 1 on the right hand side. So we will write 2 before AlCl3 to make the aluminium atoms 2 on the right hand side. So aluminium atoms are balanced now. Next we will see chlorine atoms. On the left hand side there are 2 chlorine atoms and on the right hand side there are 2 into 3, 6 chlorine atoms. So on the left hand side we will write 3 before BaCl2 to make the chlorine atoms on the left hand side 3 into 2 means 6. So chlorine atoms are balanced now. Now the whole equation is balanced. Third part, sodium and water react to make sodium hydroxide and hydrogen. First we will replace them by their chemical symbols. We will write Na for sodium, H2O for water, NaOH for sodium hydroxide and H2 for hydrogen. This is a skeletal chemical equation which we have to balance. First step is to find out the substance which has got maximum number of atoms. There are two substances H2O and NaOH who have got 3 atoms. H2O has 2 atoms of hydrogen and 1 atom of oxygen, whereas sodium hydroxide has 1 atom of sodium, 1 of oxygen and 1 of hydrogen. We can take any of these. On the left hand side there are 2 hydrogen atoms and on the right hand side there are 1 plus 2, 3 hydrogen atoms. So let us write 2 before NaOH and 2 before H2O to make the hydrogen atoms equal. Let's see how. On the left hand side there are 2 into 2, 4 hydrogen atoms. On the right hand side there are 2 into 1, means 2 plus 2, 4 hydrogen atoms. So hydrogen atoms are balanced. Let us see oxygen atoms. On the left hand side there are 2 oxygen atoms. On the right hand side there are 2 oxygen atoms. So oxygen atoms are balanced. Let us see sodium atoms. On the left hand side there is 1 sodium atom. On the right hand side there are 2 sodium atoms. So we will write 2 before Na to make the sodium atoms 2 on both the sides. Now the chemical equation is fully balanced. Third question. Write a balanced chemical equation with state symbols for the following reactions. First part. Solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. We will write BaCl2 for barium chloride, Na2SO4 for sodium sulfate, BaSO4 for barium sulfate and NaCl for sodium chloride. For aqueous solution, we will write Aq next to BaCl2, Na2SO4 and NaCl. Since barium sulfate is insoluble, so we will write S, that will be solid and it will be precipitate. So we will show precipitate symbol also. Now we are going to balance this skeletal chemical equation. Na2SO4 has maximum number of atoms. It has 2 sodium atoms, 1 sulfur atom and 4 oxygen atoms. So we will start with oxygen atoms. On the left hand side there are 4 oxygen atoms. On the right hand side there are 4 oxygen atoms. So oxygen atoms are balanced. Next we will see sodium atoms. On the left hand side there are 2 sodium atoms. On the right hand side there is only 1 sodium atom. So we will put 2 before NaCl so that the sodium atoms are 2 on the right hand side as well. Sodium atoms are balanced now. Now this is balanced chemical equation. Second part. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution and water. We will write NaOH for sodium hydroxide, HCl for hydrochloric acid, NaCl for sodium chloride and H2O for water. For aqueous solution, we will write Aq next to NaOH, HCl and NaCl. Next to H2O, we will write L, that is liquid. You will notice that this chemical equation is already balanced. Fourth question. A solution of substance X is used for whitewashing. Name the substance X and write its formula. We know that substance X is lime or quicklime, which is used for whitewashing. Its chemical formula is CaO. Second part is write the reaction of substance X with water. So CaO plus H2O will give CaOH twice and heat will be generated. Seventh question. Give examples of double displacement reactions. First example. Barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. BaCl2 plus Na2SO4 makes BaSO4 plus 2 NaCl. This is balanced chemical equation. BaCl2 consists of Ba++ and Cl- ions. Na2SO4 consists of Na+ and SO4- ions. Ba++ combines with SO4- to make BaSO4. Na+ combines with Cl- to make NaCl. Second example. Lead nitrate reacts with potassium iodide to form lead iodide and potassium nitrate. PbNO3 twice plus 2Ki makes PbI2 plus 2KNO3. Here lead nitrate consists of Pb++ and NO3- ions. Ki consists of K+ and I- ions. Pb++ combines with I- to make PbI2. K+ combines with NO3- ion to make KNO3. Eighth question. Identify the substances that are oxidized and the substances that are reduced in the following reactions. First one is 4Na plus O2 makes 2Na2O. Here sodium is gaining oxygen to form sodium oxide, so Na gets oxidized. O2 is losing oxygen, so it is reduced. Second part is CuO plus H2 makes Cu plus H2O. Hydrogen is gaining oxygen to form water, so it is oxidized. CuO is losing oxygen, so it is reduced. Now let us see exercises, questions and answers. First question, which of the statements about the reaction below are incorrect? The reaction is 2PbO plus C is making 2Pb plus CO2. First statement is lead is getting reduced. In this reaction, PbO is changing to Pb, so it is getting reduced. Means lead oxide is getting reduced. It's not lead is getting reduced. So statement A is incorrect. Statement B, carbon dioxide is getting oxidized. In this reaction, C is changing to CO2, means it is gaining oxygen or it is oxidized. So carbon is oxidized, it's not carbon dioxide is oxidized. So statement B is also incorrect, means statement A and B are incorrect. Let us see statement C, carbon is getting oxidized. In this reaction, carbon is changing to carbon dioxide, so it is oxidized. That is correct. Statement D is lead oxide is getting reduced, means PbO is getting reduced to Pb. That is correct. So only statement A and B are incorrect. So option 1, in which statement A and B are incorrect, marked is correct. Second question, Fe2O3 plus 2Al is changing to Al2O3 plus 2Fe. We have to check which type of reaction it is. First option, combination reaction. It cannot be combination reaction, as we know two or more reactant combine to make a single product. Here two products are made, so it cannot be combination reaction. Second option is double displacement reaction. We know that in double displacement reaction, reactants ions should exchange. Here ions are not getting exchanged, so it cannot be double displacement reaction. Third option is decomposition reaction. We know that in decomposition reaction, a single reactant decomposes into two or more products. It is not the case here, so it cannot be decomposition reaction as well. Last option is displacement reaction. Here we see aluminium is more reactant as compared to iron, so it displaces iron and takes its place. That's why aluminium oxide is formed. So it is displacement reaction. Third question, what happens when dilute hydrochloric acid is added to iron filings? Pick the correct answer. Hydrogen gas and iron chloride are produced, chlorine gas and iron hydroxide are produced, no reaction takes place, iron salt and water are produced. Let's try to write the chemical equation. Fe plus 2HCl makes FeCl2 plus H2, means iron chloride is formed and hydrogen gas is produced. So option A, where hydrogen gas and iron chloride are produced, is correct option. Fourth question, what is a balanced chemical equation? Why should chemical equations be balanced? Answer is, a chemical equation in which number of atoms of each element are same before and after the reaction is known as a balanced chemical equation. As per the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Fifth question, translate the following statements into chemical equations and then balance them. First part is, hydrogen gas combines with nitrogen to form ammonia. We will write H2 for hydrogen, N2 for nitrogen and NH3 for ammonia. So the skeletal chemical equation will be H2 plus N2, they form NH3. Now we will balance it. NH3 has 4 atoms, 1 atom of nitrogen and 3 atoms of hydrogen. Since hydrogen atoms are more, so we will balance it first. On the right hand side, there are 3 hydrogen atoms. On the left hand side, there are 2 hydrogen atoms. So we will take LCM of 2 and 3, that is 6. So on the both sides, we have to make 6 hydrogen atoms. On the right hand side, we will write 2 before NH3 and on the left hand side, we will write 3 before H2. So the hydrogen atoms on the left hand side are 3 into 2 and on the right hand side, they are 2 into 3, 6 hydrogen atoms. You will notice that nitrogen atoms are automatically balanced. So this is balanced chemical equation. Second part, hydrogen sulfide gas burns in air to give water and sulfur dioxide. we will write H2S for hydrogen sulfide, O2 for oxygen, SO2 for sulfur dioxide gas, H2O for water. So the skeletal chemical equation will be H2S plus O2 makes SO2 plus H2O. Now we will balance it. Hydrogen and sulfur atoms on both sides are already balanced. There are 2 hydrogen atoms on the left and 2 on the right. There is 1 sulfur atom on the left and 1 on the right. Only the oxygen atoms are not balanced. So we will balance oxygen atoms. On the left hand side, there are 2 oxygen atoms. On the right hand side, there are 2 plus 1, 3 oxygen atoms. So we will take LCM of 2 and 3, that is 6. So we will make 6 oxygen atoms on both the sides. On the left hand side, we will write 3 before O2, and on the right hand side, we will write 2 before SO2 and 2 before H2O. So on the right hand side, there are 2 into 2, 4 plus 2 into 1, 2, that is equal to 6. So total 6 oxygen atoms will be there on the right hand side. So oxygen atoms are balanced. While balancing oxygen atoms, hydrogen and sulfur atoms have become unbalanced. So we will balance them. On the right hand side, there are 2 into 2, 4 hydrogen atoms. On the left hand side, there are 2 hydrogen atoms. So we will write 2 before H2S to make 2 into 2, 4 hydrogen atoms on the left hand side as well. Now sulfur atoms on the right hand side are 2 and on the left hand side 2. So sulfur also is balanced now. So this is a balanced chemical equation. Third part, barium chloride reacts with aluminium sulfate to give aluminium chloride and a precipitate of barium sulfate. We have already solved this question before, so you can try on your own and match the answer. So balanced chemical equation is 3BaCl2 plus Al2SO4 thrice makes 3BaSO4 plus 2AlCl3. Last part, potassium metal reacts with water to give potassium hydroxide and hydrogen gas. We will write K for potassium, H2O for water, KOH for potassium hydroxide and H2 for hydrogen. So the unbalanced chemical equation will be K plus H2O makes KOH plus H2. Following the same balancing method, the balanced equation will be 2K plus 2H2O makes 2KOH plus H2. Sixth question, balance the following chemical equations. You have to balance these chemical equations. Follow the method we have already discussed and match your answers. Pause the video to match your answers. Seventh question, write the balanced chemical equations for the following reactions. You may give it a try and check your answers here by pausing the video. I will slowly scroll the page so you can refer the answer of the remaining questions. Before starting competition level questions, let us see few more important points. First point is, temperature of the container rises in case of exothermic reactions due to the liberation of heat energy. Second point is, all displacement reactions are exothermic reactions. Third point is, reactivity series of metals is this. We will see few questions based on the reactivity series. Fourth point, oxidizing agent reduces while reducing agent oxidizes in a chemical reaction. For example, in this chemical reaction, hydrogen gains oxygen to form H2O, so it oxidizes. At the same time, it works as a reducing agent for CuO, which loses oxygen to form Cu. Similar way, CuO, which reduces to Cu after losing oxygen, works as oxidizing agent for H2, which gains oxygen to form H2O. Now let us see some named reactions. First one is neutralization reaction. When an acid reacts with a base, it forms salt and water. This type of reaction is called neutralization reaction. For example, HCl plus NaOH makes NaCl plus H2O. Second one is combustion reaction. A chemical reaction in which a fuel undergoes oxidation resulting in the release of heat energy is called a combustion reaction. For example, burning of natural gas CH4 plus 2O2 makes CO2 plus 2H2O plus heat. Third one is esterification reaction. When a primary alcohol is treated with a carboxylic acid in the presence of sulfuric acid, a sweet smelling compound called ester is formed. This chemical reaction is known as an esterification reaction. C2H5OH plus CH3COH in presence of sulfuric acid makes CH3COO C2H5 plus H2O. The main identification of this type of reaction is an alcohol will react with an acid. Now let us see some NCERT exemplar questions. First question is, the following reaction is an example of a displacement reaction, combination reaction, redox reaction, neutralization reaction. And the reaction is 4NH3 plus 5O2 makes 4NO plus 6H2O. Now let us analyze. In this reaction, O2 is displacing hydrogen from NH3 to make NO. So this is displacement reaction. The second option is combination reaction. It cannot be combination reaction because in combination reactions, two or more reactants make a single product. Here two products are getting made, so this cannot be combination reaction. Third one is redox reaction. Let us see. NH3 loses hydrogen to form NO, so it is getting oxidized. At the same time, O2 is gaining hydrogen to make H2O, means it is getting reduced. So this is redox reaction. Fourth one is neutralization reaction. It cannot be neutralization reaction because in neutralization reaction, one acid reacts with one base to form salt and water. That is not the case here. So the correct options are 1 and 3. And the correct option is C, which says 1 and 3 are correct statements. Second question, which of the following statements about the given reaction are correct? The reaction is 3Fe plus 4H2O makes Fe3O4 plus 4H2. First statement is iron metal is getting oxidized. Second is water is getting reduced. Third is water is acting as reducing agent. Fourth is water is acting as oxidizing agent. Let us see. Fe is gaining oxygen to form Fe3O4. So it is getting oxidized. First statement is correct. H2O is losing oxygen to form H2. So it is getting reduced. So the second statement is also correct. Third statement is water is acting as reducing agent. Let us see. H2O is losing oxygen to form H2. So it works as oxidizing agent for iron. So third statement is wrong. Fourth statement is water is acting as oxidizing agent. That is correct. So the correct statements are first, second and fourth. And the option C, which says first, second and fourth are correct statement, is the right choice. Third question, which of the following are exothermic processes? First reaction is reaction of water with quicklime. That means CaO plus H2O makes CaOH twice plus heat. Means this is exothermic reaction. Second one is dilution of an acid. When water is mixed in concentrated acid, heat energy is liberated. So this also is exothermic reaction. Third one is evaporation of water. It is endothermic reaction because water absorbs heat to evaporate. So this is endothermic reaction. Fourth one is sublimation of camphor. Camphor absorbs heat to sublimate. So this also is endothermic reaction. So the correct options are option 1 and 2. And the correct choice is A, which says 1 and 2 are correct. Fourth question, a dilute ferrous sulfate solution was gradually added to the beaker containing acidified permanganate solution. The light purple color of the solution fades and finally disappears. Which of the following is the correct explanation for the observation? So these are the four explanations given. The balanced chemical equation for this reaction is given as 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 thrice plus K2SO4 plus 2 MnSO4 plus 8 H2O. Potassium permanganate KMnO4 reacts with ferrous sulfate FeSO4 to make ferric sulfate Fe2SO4 thrice. The number of oxygen atoms in ferrous sulfate are 10 into 4, that is 40. The number of oxygen atoms in ferric sulfate are 4 into 3, that is 12 into 5, that is 60. So ferrous sulfate is gaining 20 atoms of oxygen to make ferric sulfate. So it is getting oxidized, and the oxidizing agent is KMnO4, that is potassium permanganate. So the option A that says KMnO4 is an oxidizing agent, it oxidizes FeSO4 is correct. Fifth question, in the double displacement reaction between aqueous potassium iodide and aqueous lead nitrate, a yellow precipitate of lead iodide is formed. While performing the activity, if lead nitrate is not available, which of the following can be used in place of lead nitrate? So these four options are given. So this is the chemical equation. PbNO3 twice plus 2Ki makes PbI2 plus 2KNO3. We know that PbNO3 twice is made of Pb++ and NO3- ions. Lead nitrate's replacement should look very similar to it. Let us see the options given. First one is lead sulfate. Lead sulfate is written as PbSO4. It is made of Pb++ and SO4- ions. So it is not similar to Pb++ and NO3-. So it is not the correct option. Second option is lead acetate. Lead acetate is written as PbCH3COO twice. It is made of Pb++ and CH3COO- ions, which is very similar to Pb++ and NO3- ions. So this is the correct option. Let us see the other options as well. Option C is ammonium nitrate, means it is written as NH4NO3. It is made of NH4+ and NO3- ions. So this is not the correct option. Last option is potassium sulfate. It is written as K2SO4. It is made of K+ and SO4- ions. It is not similar to Pb++ and NO3-. So this also is not the correct option. So the correct option we have found is option B, lead acetate. Now let us see short answer questions. Question number 6. Write the balanced chemical equations for the following reactions and identify the type of reaction in each case. First one is nitrogen gas is treated with hydrogen gas in the presence of a catalyst at 773 Kelvin to form ammonia gas. The balanced chemical equation is N2 plus 3H2 in presence of catalyst and at 773 Kelvin makes 2NH3, and the type of reaction is combination reaction. Second reaction is sodium hydroxide solution is treated with acetic acid to form sodium acetate and water. Balanced chemical equation is given as NaOH aqueous plus CH3COOH aqueous gives CH3CONA aqueous plus H2O liquid. This is double displacement reaction. As we know, NaOH is made of Na plus and OH minus ions. CH3COH is made of CH3COO minus and H plus ions. Na plus combines with CH3COO minus ion to make CH3CONA, and H plus combines with OH minus to make H2O. So this is double displacement reaction. This is also neutralization reaction. As we know, in neutralization reaction, one acid reacts with one base to make salt and water, and this is the case here. Acid CH3COH reacts with base NaOH to make salt CH3CONA plus water H2O. Third reaction, ethanol is bound with ethanoic acid to form ethyl acetate in the presence of concentrated H2SO4. Balanced chemical equation is given as ethanol, that is ethyl alcohol C2H5OH aqueous plus ethanoic acid, that is CH3COH aqueous, in presence of concentrated H2SO4 represented as H plus, gives CH3COO C2H5 aqueous plus H2O liquid. This is double displacement reaction. As you can see, C2H5OH is made of C2H5 plus and OH minus. CH3COOH is made of CH3COO minus and H plus. C2H5 plus combines with CH3COO minus to make CH3COO C2H5, and H plus combines with OH minus to make H2O. So this is double displacement reaction. This is also esterification reaction. As you can notice, one alcohol C2H5OH reacts with one acid CH3COOH to make ester CH3COO C2H5 and water. Last reaction is ethene is burned in the presence of oxygen to form carbon dioxide, water, and releases heat and light. Balanced chemical equation is given as C2H4 plus 3O2 gives 2CO2 plus 2H2O plus heat and light. This is redox reaction as well as combustion reaction. Let us see how. C2H4 loses hydrogen to form CO2, so it is getting oxidized. O2 gains hydrogen to form H2O, so this is reduced. So this is redox reaction. Since C2H4 is combining with oxygen to form CO2, water, heat and light, so it is combustion reaction. Seventh question. Complete the missing components or variables given as X and Y in the following reactions. First reaction is PbNO3 twice aqueous plus 2Ki aqueous makes PbI2X plus 2KNO3Y. We know that PbI2 is solid, so in place of X it will be written as S. And we know that KNO3 is aqueous, so in place of Y, AQ will be written. Second reaction, CuS plus 2AgNO3 aqueous makes CuNO3 twice aqueous plus XS. Balanced chemical equation is given as CuS plus 2AgNO3 aqueous makes CuNO3 twice aqueous plus 2AgS. So in place of X, 2Ag will be written. Third reaction is ZnS plus H2SO4 aqueous makes ZnSO4 X plus H2Y. Balanced chemical equation is given as ZnS plus H2SO4 aqueous makes ZnSO4 aqueous plus H2 gas. So in place of X, AQ will be written. In place of Y, G will be written. Last reaction, CaCO3S, X above the arrow, CaOS plus CO2G. We know that when CaCO3 is heated, makes CaO solid plus CO2 gas. So in place of X, heat will be written. Eighth question, identify the reducing agent in the following reactions. In these reactions, we need to identify which reactant is getting oxidized. That reactant will work as reducing agent for other reactant. First equation is 4NH3 plus 5O2 makes 4NO plus 6H2O. Here NH3 is losing hydrogen to form NO. That means it is getting oxidized. So it will work as reducing agent for oxygen. So NH3 works as reducing agent. Second equation is H2O plus F2 makes HF plus HOF. Here H2O is losing hydrogen to form HOF. So it is getting oxidized. It will work as a reducing agent for F2. Third equation is Fe2O3 plus 3CO makes 2Fe plus 3CO2. Here CO is getting oxygen to make CO2. So it is getting oxidized. It will work as a reducing agent for Fe2O3. Last equation is 2H2 plus O2 makes 2H2O. Here H2 is gaining oxygen to make H2O, so it is getting oxidized. It will work as a reducing agent for O2. Ninth question, why do fireflies glow at night? Answer is, fireflies secrete luciferase enzyme. When the oxygen combines with calcium, ATP and luciferin in the presence of luciferase, a new substance named oxyluciferin is formed along with the evolution of energy in the form of light. Now let us see long answer questions. Question number 10. On heating blue colored powder of copper nitrate in a boiling tube, copper oxide, which is black in color, oxygen gas, and a brown gas X is formed. First part, write a balanced chemical equation of the reaction. So the balanced chemical reaction is 2CuNO3 twice solid when heated makes 2CuO solid plus 4NO2 gas plus O2 gas. Second part is identify the brown gas X evolved. Brown gas is nitrogen dioxide NO2. Third part is identify the type of reaction. This is decomposition reaction as a single substance is getting decomposed to two or more products. Last part is what could be the pH range of the aqueous solution of the gas X. When NO2 reacts with water, it makes HNO2 and HNO3, two acids. Balanced chemical equation is 2NO2 plus H2O makes HNO2 plus HNO3. Since the product is acidic, so pH range will be less than 7. Question number 11. Give the characteristic tests for the following gases: CO2, SO2, O2 and H2. First one is carbon dioxide. When carbon dioxide gas is passed into lime water, it turns lime water milky due to the formation of insoluble calcium carbonate, and the reaction is given by CaOH twice plus CO2 makes CaCO3 plus H2O. Second one is sulfur dioxide. Sulfur dioxide gas is a strong reducing agent. When passed through acidic potassium permanganate solution, which is purple in color, turns it colorless. Reaction is given as 2KMnO4 plus 5SO2 plus 2H2O makes K2SO4 plus 2MnSO4 plus 2H2SO4. Third one is oxygen. The evolution of oxygen gas during a reaction can be confirmed by bringing a burning candle near the mouth of the test tube containing the reaction mixture. The intensity of the flame increases because oxygen supports burning. Hydrogen gas. Hydrogen gas burns with a pop sound when a burning candle is brought near it. This happens because of the combustion of hydrogen gas. Question number 12. You are provided with two containers made of copper and aluminium. You are also provided with solutions of dilute HCl, dilute HNO3, ZnCl2 and H2O. In which of the above containers these solutions can be kept? First we will see reaction between copper and these compounds. Then we will see reaction between aluminium and these compounds. Copper does not react with dilute HCl. So dilute HCl can be stored in a copper container. Copper reacts with dilute HNO3. So dilute HNO3 cannot be stored in a copper container. Reaction takes place like this. 3Cu plus 8HNO3 makes 3CuNO3 twice plus 2NO plus 4H2O. Copper is less reactive than zinc. It cannot displace zinc from zinc chloride solution. So zinc chloride can be stored in a copper container. Copper does not react with water, so water can be stored in a copper container. Let us see the reactivity of aluminium with these compounds. Aluminium reacts with dilute hydrochloric acid to form its salt. So dilute HCl cannot be stored in an aluminium container. Reaction takes place like this. 2Al plus 6HCl makes 2AlCl3 plus 3H2. Aluminium reacts with HNO3 to form a passive layer of aluminium oxide, which protects aluminium from further oxidation. So dilute HNO3 can be stored in an aluminium container. Aluminium is more reactive than zinc. It displaces zinc from zinc chloride. So dilute zinc chloride cannot be stored in aluminium container. The reaction takes place like this. 2Al plus 3 ZnCl2 makes 2AlCl3 plus 3Zn. Aluminium does not react with cold water. Aluminium reacts with steam to form a passive layer of aluminium oxide which protects it from further oxidation. So water can be stored in aluminium container. Now let us see few Olympiad questions. I have taken these questions from NSO Olympiad workbook by MTG Learning. Question number 13. 4 students P, Q, R and S noted the initial color of the solutions kept in beakers 1, 2, 3 and 4. After inserting zinc rods in each solution and leaving them undisturbed for 2 hours, the color of each solution was again noted in the form of table given below. Now, based on the reaction between zinc and aluminum sulfate, zinc and zinc sulfate, zinc and iron sulfate, and zinc and copper sulfate, 4 students observed the color change and noted down as in this table. Now we have to reply which student noted the color change in all the 4 beakers correctly. Let us see chemical reactions taking place in all the 4 beakers one by one. In first beaker, zinc is supposed to react with aluminum sulfate. Zinc is less reactive than aluminum. It cannot displace aluminum from aluminum sulfate solution. So no reaction will take place, means there will not be any change in color of the solution. In second beaker, zinc is supposed to react with zinc sulfate. So zinc cannot displace itself, or even if it displaces, no new product is formed. So no reaction in this case also. So no change in the color of the solution. In third beaker, zinc is supposed to react with iron sulfate. Zinc is more reactive than iron as per reactivity series. So zinc will replace iron from iron sulfate solution and make zinc sulfate. So there will be change in color of the solution. In fourth beaker, zinc is more reactive than copper. So zinc will replace copper from copper sulfate solution and make zinc sulfate. So again change in color of the solution in fourth beaker. So let us see the table once again. Let us see observation of student P. In first beaker, he doesn't see any change in color, that is correct. In second beaker, he doesn't see any change in color, that is correct. In third beaker, from light green to colorless, that is also correct. In fourth beaker, from blue to colorless, that is also correct. Means student P got all the observations correct. So option A is correct. Question number 14. Lead nitrate crystals are burned in air. Which of the following observations are correct? First one is a double displacement reaction takes place. Second one is brown fumes of NO2 are evolved. Third one is black residue is left behind in the test tube. Let us write the chemical equation first. Chemical equation is 2PbNO3 twice decomposes to 2PbO plus 4NO2 plus O2. So the first statement that says a double displacement reaction takes place is wrong. This is decomposition reaction, not double displacement reaction. Second is brown fumes of NO2 are evolved. This is right. Third is black residue is left behind in the test tube. It is not the black residue, it is yellow residue or PbO that is left behind in the test tube. So statement 3 is also incorrect. Only statement 2 is correct. Option D that says only statement 2 is correct is the right choice. Last question. Rupali, a class 10 student, has set up the apparatus as shown in the figures. In first beaker, 20 ml of water plus K2SO4 is there. In second beaker, 20 ml of water plus NH4NO3 is there. In third beaker, 20 ml of water plus anhydrous CuSO4 is there. In fourth beaker, 20 ml of CuSO4 plus zinc granules are there. Which of the following observations is correct? Observation A. Temperature of beakers 1, 2 and 3 will be raised as dissolution of salts is an exothermic process. Observation B. Temperature of beakers 1, 3 and 4 will be raised while temperature of beaker 2 will fall. Observation C. Temperature will rise only in beaker 4 as redox reactions are exothermic. And option D. None of these. Let us find out. In beaker 1, K2SO4 dissolves rapidly in water, so it is exothermic reaction, means temperature of this beaker will rise. In beaker 2, NH4NO3 absorbs energy from the water, it is endothermic reaction, so temperature of beaker 2 will fall. In beaker 3, copper sulfate will react with water and water molecules will be attached to it and heat will be liberated. So it is exothermic reaction, means beaker 3's temperature will rise. In beaker 4, zinc will react with copper sulfate to make zinc sulfate and copper plus heat will be liberated. So it is exothermic reaction, means beaker 4's temperature will also rise. So temperature of beaker 1, 3 and 4 will rise, whereas beaker 2's temperature will fall. So option B is the correct one. You may practice more competition level questions. Links are given in the description box below. If you want to ask questions, you may join my Discord server. If you have not yet subscribed my YouTube channel, please do so.